So now let's look at the curl and Laplacian and some other second derivatives which we can construct from the gradient, divergence and the curl. Okay. So this is our lecture 5 in the series of electromagnetic theory. We have discussed about the divergence, we have discussed about the gradient, and we also discussed about some other vector calculus introduction. Okay. So now I will define what is the curl, and then we will look at some operators which we call the Laplacian operator, and some other second derivative also we will look at. Okay. So mathematically the curl is defined as del cross V. Okay. So this is the cross product between the del and this V is some vector function. Okay. This is some vector. So when you take the cross product, and in the earlier lectures we have defined how to take the cross product. So this is the way to get the cross product between two vectors. Now this del is operator. Okay, this is not a vector, so do not confused that so do not take it literally as a vector. Yes, it is in the form of x cap, y cap, z cap, but it is not actually a vector. So this is the right way to say that whenever we are operating this delta operator on a vector function, and when you are taking the cross product, then this operation is called the curl. So this is what we call, so this is what we call curl. Okay, curl of a vector V. So now you can take the curl by calculating this determinant, and you will get the curl, and when you will solve this determinant you will get this expression. Okay, so this is how you take the curl. In earlier lecture, so let me again define the three operations which we have done. First was the gradient, and gradient was simply operated upon the scalar function. Okay, so when you operate upon a scalar function f, this operator delta, then we call this gradient. And when you take the dot product del dot some vector function, okay, now this is vector, this f was a scalar in the case of gradient. When you take the dot product, it is our divergence. Yes, and when you take the cross product now, this is what we call the curl. Okay, that is fine. Now let's look at geometrical intuition as we have discussed in the case of gradient and the divergence. Let's look at the geometrical interpretation of the curl. So let's say this is our a vector field, this is our vector which is in the terms of y and the x. Okay, and when you will draw this vector on the xy plane, you will be getting this vector field. Okay, this vector field it simply means when you draw all the vectors at all the points in the xy plane. Okay, so you just put simply the y value of the x and y, you will be getting this kind of vectors, okay, in the xy plane. So now by looking at this vector field, you can see that this is kind of rotational. Okay, this is kind of rotational vector field. Yes, so there is a rotation in this vector field, and that is what we also call the curl, that this vector field is having curl, this vector field is having non-zero curl. Okay, so curl in the English meaning also, it is like kind of rotation. Yes, so if you see, this is rotating in this direction, vector field is rotating in this direction. So if you assume this vector as a velocity of some particles of the any fluid or water, let's say, then the water or the fluid is flowing in this direction. Yes, and if you take the right hand rule, if you try to get into the direction of the curl, then if you curl around your fingers of right hand into the direction of this flow, then the direction of thumb would be in the direction of Z. Yes, so this would be the direction of your resultant curl. So when you are taking curl del cross B, as we see, the curl or the cross product gives you the vector. Yes, and the dot product gives you a scalar, but cross product gives you a vector. So this is the intuition. Now if you calculate this curl mathematically by this expression, then you will find this expression as 2z cap. As we can easily see from this picture, yes, as we can easily see that curl will be in the direction of z, because if you apply the right hand rule, the direction would be easily could be guessed. Yes, so this is also we are getting from the mathematical equation, and this is also we are getting from the intuition. Now for getting the intuition from the picture, you have to draw the vector field obviously, but I wanted to give you the geometrical meaning of the curl. Okay, so now let's say I have a vector field. Let's say I am drawing let's say my vector is half x cap. Okay, so this is my vector, and if you will draw the vector field for this vector, then you will be getting vector field like this. So at higher value of x, the magnitude would be larger, and for lower value of the x, the magnitude would be small. And here we do not have any y component and the z component, so in the direction of y, the vector would be the constant. Okay, so like y is in this, at this x value, the magnitude would be higher. Okay, now if you see what is the value of curl, so without calculating it from this expression, you can easily see there is no rotation. Yes, there is no rotation either in the clockwise or in the anti-clockwise direction. There is no rotation, so we can simply say their curl is 0. Yes, because these vectors are pointing in this x cap direction and there is no rotation. So if you like assume that these vectors are showing the velocity or the some water movement, then you can say there is no rotation of the water movement. Yes, so simply the curl is 0. And if you calculate from this expression mathematically also, you will be getting the curl is equal to del cross V is equal to 0. Okay, so if you know the intuition and the geometrical meaning of the curl, you can simply by looking at the expression, you can say curl is equal to 0. So sometimes we also denote in the GATE exam, it is also asked in the terms of like whether this vector field is rotational free. Okay, so it is irrotational. Yes, because irrotational means simply the rotation is not present there. So rotation means the curl is 0. So if curl is 0, that means there is no rotation. That means it is irrotational. Okay, so it's like if you assume this is the fluid, and if you put some particle or some stone like in this fluid, then this stone will be going into the direction of this x cap direction. Yes, and there would be no rotation. Okay, that is fine. So that is the meaning of the curl simply. Yes, now okay, maybe I will be making the next video to discuss about what is the Laplacian and what are the some other second derivatives. Okay, so stay tuned to the next video. Thank you.